Okay, let's look at a little more history. I like to call this the parallel boy that lived, databases being that boy. So in the 1980s, one of the big challenges in computer science was to parallelize software. And one of the ideas was they would take regular C programs, which were the programs people tended to work with in the 80s, and new compilers would somehow auto-parallelize them. Another option was to change C a little bit for parallelism and get people to program differently to achieve parallelism. And in broad terms, both of those approaches failed. And the companies that grew up to build specialized computers for these specialized forms of parallelism also mostly failed. So Dave Patterson, Turing Award winner in computer architecture, has referred to these companies from the 1980s as the Dead Computer Society. It's a bunch of interesting hardware companies that failed. So the exception to this were the companies that built hardware for parallel SQL databases, notably a company called Teradata, which is still around today. They co-designed a relatively commodity cluster of computers with a fast network and a software solution for parallel databases. And that has remained a successful pairing of hardware and software to this day, not only at Teradata, but really at every database company running on commodity hardware. And why did this work? Well, largely because of data independence. So SQL is independent of how many machines you have, and the applications that needed to use databases did not change with the advent of parallelism. So there was no need for us to teach people to program differently. And then, of course, the second piece of it is that under the covers, the same divide and conquer that worked for disks works across machines. Big data, in some sense, is just the generalization of these lessons. In many cases, a relearning of them because the big data community, many of those folks didn't know about parallel databases or didn't really understand the lessons there, and so revisited a lot of them.